This is a rectifier regulator, and I'm going to show you how Outboards use these to change AC to DC electricity and how you can test it. Inside of our rectifier here, we have a set of diodes that are going to control the flow of the voltage coming from the stator. And all a diode does is it allows current to flow in one direction, but not in the other direction. And if we take a set of diodes, we can actually convert the AC to DC, which is exactly what our rectifier is doing. Now there are two ways that it can do this. One is called a half wave rectification and two is called a full wave rectification. One uses a single diode and the other one uses a set of diodes, usually 4 different diodes called a bridge. And in the world of Outboards, most of the rectifiers use the bridge setup or more than one diode because it is more efficient. The big difference in the half wave and the full wave is that the half wave only allows 1/2 of the sine wave to go through. So it's not as efficient as allowing both of them to go through, only converting the negative to a positive and allowing only positive voltage to flow in one direction. That is why in the world of Outboards, most of them use a full wave or a bridge set of diodes to convert the AC to DC. When it comes to testing the rectifier, we're going to be using a digital multimeter, and it is very important that you understand and use the correct selection on the meter, because if you use the wrong one, it's not going to work properly when it comes to testing it. The setting that we are going to be using is the diode test. Now that is not to be confused with an ohms or a resistance test. It's very important that you do not confuse these two settings, because a lot of people use an ohms test and they call it a continuity test. I don't care either way what you call it, because you could consider it a continuity test, even though when you check for resistance, that's what you're doing. You're using an ohms setting to check for the ohms or resistance that is on a specific line. And you can say it has continuity or it does not have continuity. But when you're talking about diodes, it is very important that you differentiate the two words, because continuity is really about the diode test, because the continuity test really takes voltage from one meter lead and passes it over to the other meter lead, usually around 2.5 volts, and it waits to see if it comes back. If it sees 100% of that voltage, then it gives you a continuity of the wire, which is what we're trying to do with the diode. We're trying to make sure that it has continuity in one direction, but that it does not have continuity in the other direction. And it's important that you don't confuse these two, because a resistance test or an ohms test really tests both directions. It doesn't really care whether it's going one way or the other way. So you will see continuity if there's continuity in one direction, but that doesn't mean that in a diode test, that is the correct way to do the test. So remember, it's very important to use the diode setting and not an ohms resistance test. We are checking for continuity, but we're checking for continuity in one direction and not the other. And if we look on our meter here and change it over to our setting, you can see that right now it is on an ohms test. So you're going to be doing a resistance test. If we hit this little button here, which gives us that symbol is for a diode. If you hit that, that turns the alarm on. But if you hit it again, boom, you see that little symbol right there? That is a symbol for a diode. And that is the setting that we're going to want to check with. And now that you understand that, we can actually go into testing the actual rectifier regulator. Now, we are going to be testing a single phase rectifier regulator. There is also a triple phase rectifier regulator, but as long as you can understand and do the single phase, the triple phase is pretty much identical. And the most important thing that you need to have is this right here. This is going to be the service manual specs for the rectifier that you're going to be using, or the one that you're going to be testing. Now when it comes to actually reading this sheet, it's actually very, very simple. Main thing that you need to understand is this line right here going down the middle of this box. That line tells you which meter lead is going to go where. This is our positive meter lead, and this is our negative meter lead. So always make sure, if you've got it on the green and the green blue, you're looking for no continuity between the green on the red lead and the green blue on the black lead. So in practicality, what this says is continuity means you're going to have continuity there, or you're going to get the alarm. And then this symbol here is the infinity symbol, and that means that it is completely disconnected with no continuity between these two leads. Okay, so we are on our diode section there. And I think I told you wrong, because looking at this now, this is our ohms reading, and that is going to be the sound, but that is a continuity buzzer. Actually, looking at this here, yeah, my continuity buzzer is 0.4 to 0.6, so that's going in both ways. So make sure you're only using that diode test, which is 2.7 volts, not 2.5, but gonna hit that, go to our diode section, and our red lead is going to be going to our green, which is this one right here. And then our black lead is going to be going to our green blue lead. That has 1.343, which is not supposed to have any continuity at all. And so this rectifier regulator is messed up. We got our green lead, positive, going to our blue lead, which is, you know, green is number 2 and blue-green is 1. Doesn't matter if it's this one or if it's this one. But yeah, we've got 1.342 on the diode, which means that this is a bad rectifier regulator. We have a diode that is popped on the inside of this. Now, if we continue our test, though, just to see what else is messed up, our red, it's going to go to our red, and then our next one, our black, is supposed to be on green. And we have no continuity, which we're supposed to have continuity on here. So that means that that diode on the green-blue, somewhere that thing's been popped. Now, if I go to our red lead to our black, that is also supposed to have no continuity, and it has 0.508 volts. So that thing is, this is bad. Now, moving on, if we get our red lead to our red wire and our black going to our green, we're going to be testing things in the opposite direction. So that's that. And we're going to go there. We're supposed to have continuity, and we have no continuity. And now to our black, supposed to have continuity. We do have continuity, which that is a good thing. Moving on, our black is going to be going to our red wire, and our red wire is going to go to our blue-green. That is not supposed to have any continuity at all, and we've got 0.510 volts, so that thing is messed up. And if we take our red back over here to our green wire, not supposed to have any continuity, and we got 0.428, so that's not good there. And then finally, our last test is going to be our black on black, and we're going to be checking our black to the green. It's supposed to have continuity. We have 0.9, so that one's good. Now our green blue, supposed to have continuity. We have no continuity at all, so that circuit is also blown. And then finally to our red, which we're supposed to have no continuity, or we are supposed to have continuity, and we have no continuity. So there is a diode that has been popped here. Maybe the red wire got touched to ground at some point and it blew all the diodes in this, which is very possible. But that shows us that this rectifier regulator is messed up and blown, and it is no good, basically. So that is how you test these. And no matter what you do, as long as you have that sheet and you know that you're on the diode test, you just run through the chart. Positive to whatever wire it wants you to, negative to whatever wire it wants you to, and then make sure you get the results that it shows you you're supposed to get. And again, don't worry so much about the numbers on a rectifier regulator like this, because it doesn't even give you any numbers to compare to. This is more important on the voltage flowing in one direction and not in the other direction. Now, on other rectifier regulators like a triple phase or a 3-phase, whatever you want to call it, that has a different setup to it. There are upper and lower diodes, and you can test them in specific directions. Those will actually give you numbers to compare to, and they will want you to be in a specific range of numbers. Now, when you are testing something like that, you need to start paying attention to those numbers, because they do matter on how much voltage it is supposed to let through and how much it is not supposed to let through. So just make sure that you stick to the sheet based on the rectifier regulator that you are testing, based on whichever one that you have. And that is going to be the best way for you to test a rectifier regulator.